My dear students, now I am going to explain batteries. See, in batteries, chemical energy is converted into electrical energy. In batteries, chemical energy is converted into electrical energy. These batteries are two types, primary batteries and secondary batteries. Primary batteries and secondary batteries. These primary batteries are not chargeable. These are not chargeable, but these are rechargeable. Primary batteries are not chargeable. See, because in primary batteries, reactions occur only once. In primary batteries, reactions occur only once. After use of over a period of time, primary batteries become dead. Hence, they cannot be used, they cannot be reused again and again. But in case of secondary batteries, reactions can be reversed. That's why secondary batteries can be reused. Primary batteries are not chargeable because in primary batteries, reactions occur only once. After use of over a period of time, primary batteries become dead. Primary batteries become dead. Hence, they cannot be reused again and again. But secondary batteries are rechargeable because in secondary batteries, that reactions can be reversed. So these are rechargeable. These for these primary batteries, example, see first one, dry cell or Leclanche cell. For primary batteries, example, dry cell or Leclanche cell. Second one, mercury cell. Mercury cell. For secondary batteries, example, lead storage battery. Lead storage battery. Second one, nickel cadmium cell. For primary batteries, example, this is dry cell or Leclanche cell. Second one is mercury cell. For secondary batteries, example, lead storage battery and nickel cadmium cell. See, first let me explain this dry cell or Leclanche cell. See, dry cell or Leclanche cell. Dry cell or Leclanche cell. See, in this dry cell or Leclanche cell, one zinc container is there. Itself it acts as anodes. In this dry cell, one zinc container, zinc vessel. This is a zinc container. Itself it acts as anodes. So in this dry cell, anode is a zinc container. Next, cathodes. See, in this zinc container, one graphite rod is immersed. One graphite rod is immersed. It acts as cathodes. Graphite rods. One graphite rod is there. This graphite rod acts as cathodes. This graphite rod is surrounded by powdered manganese dioxide and carbon. Graphite rods surrounded by powdered manganese dioxide and carbon. This is graphite rods. This graphite rod is surrounded by powdered manganese dioxide and carbon. So here this is zinc container, zinc vessel. This is anodes. This graphite rods, which is surrounded by powdered manganese dioxide and carbon. It acts as cathodes. So these two are the electrodes. These two electrodes are separated by moist ammonium chloride plus zinc chloride. This is anodes. This zinc container is anodes. This graphite rod, which is surrounded by powdered manganese dioxide carbon, which acts as cathodes. Both the electrodes are separated by, means here both the electrodes are separated by moist ammonium chloride plus zinc chloride. In this dry cell at anode this reaction takes place. We know that at anode oxidation. At anode this reaction takes place. Zinc loses 2 electrons and forms Zn plus 2. At cathodes we know that reduction reaction takes place. At cathodes, see, MnO2 plus NH4 plus electrons. At cathode, gain of electrons gives rise to MnOOH plus NH3. At anode, this reaction takes place. At cathode, this reaction takes place. So here, see, at cathodic reaction, at anode, oxidation number of manganese is plus 4. In MnO2, oxidation number of manganese is plus 4. Product side, here oxidation number of manganese is plus 3. For oxygen minus 2, OH minus 1. For manganese plus 3. So here oxidation number of manganese changes from plus 4 to plus 3. In dry cell, at a cathodic reaction, oxidation number of manganese changes from plus 4 to plus 3. Here this ammonia is liberated. That ammonia combines with the zinc ions and form complex compounds. Zn plus 2 plus ammonia molecules gives rise to Zn NH3 taken 4 plus 2. This complex compound is formed. This is dry cell or Leclanche cell. These dry cells are used in transistors and clocks. Dry cells or Leclanche cells are used in transistors and clocks. It has a potential of 1.5 volts. This dry cell has a potential of 1.5 volts. Here everything is almost memory based only. You should remember everything. In dry cell or Leclanche cell, anode is zinc container. That zinc container is there itself, it acts as anodes. One graphite rod is immersed into that zinc container. It acts as cathodes, which is surrounded by powdered manganese dioxide and carbon. Both the electrodes are separated by moist ammonium chloride plus zinc chlorides. At anodes, this reaction takes place. At cathode, this reaction takes place. Here oxidation number of manganese changes from plus 4 to plus 3. This ammonia liberated combines with zinc ions and form complex compounds or coordinate covalent compounds. This dry cell is used in transistors and clocks. It has a potential of 1.5 volts. This is about dry cell. Next, second one is mercury cell. Second one is mercury cell. In this mercury cell, see, anode is zinc mercury amalgam. In mercury cell, anode is zinc mercury amalgam. Anode is zinc mercury amalgam. ZnHg. In this mercury cell, anode is zinc mercury amalgam. Next, cathodes. Cathode is moist mercury oxides and carbon. Cathode is moist mercury oxides plus carbon. It acts as cathodes. And electrolyte. Electrolyte is mercury oxides, potassium hydroxide plus zinc oxides. In this mercury cell, electrolyte is potassium hydroxide plus zinc oxides. In mercury cell, anode is zinc mercury amalgam, cathode is moist mercury oxide plus carbon, electrolyte is potassium hydroxide plus zinc oxides. At anodes, we know that oxidation takes place. Zinc amalgam plus OH minus ions. Here electrolyte is potassium hydroxide and zinc oxides. Gives rise to zinc oxides plus H2O. At anode, oxidation takes place. Oxidation means loss of electrons. So zinc amalgam plus OH minus ions gives rise to zinc oxide plus H2O plus 2 electrons. Next, at cathodes. At cathode, reduction reaction takes place. Mercury oxides plus H2O plus 2 moles of electrons. At cathode, reduction means gain of electrons. Gives rise to mercury plus 2 moles of OH minus ions. Everything is balanced. Overall reaction. Overall reaction. Water will get cancelled, electrons will get cancelled, OH minus ions will get cancelled. Then overall reaction is zinc amalgam plus mercury oxides gives rise to zinc oxides plus mercury. This is overall reaction. In this mercury cell, this is anode, this is cathode, electrolyte is this one, this is anodic reaction, this is cathodic reaction, this is overall reaction. These mercury cells are used in hearing aids and watches. Used in hearing aids and watches. Hearing aids and watches. Mercury cells are used in hearing aids and watches. It has a potential of 1.35 volts. So these two are the primary batteries. These are not rechargeable. These are not chargeable. So now secondary batteries. For secondary batteries also we have two examples. First one is lead storage battery. Second one is nickel cadmium cell. See, first one, lead storage battery. Lead storage battery. See, that lead storage battery, anode is lead. In lead storage battery, anode is lead. So this lead storage battery, it is used in automobiles and inverters. Lead storage battery is used in inverters and automobiles. So anode is lead, cathode. Cathode is grid of lead. Grid of lead packed with lead dioxide. Anode is lead, cathode is grid of lead packed with lead dioxide. Next, electrolytes. Electrolyte is 38% sulfuric acid. Electrolyte is 38% sulfuric acid. At anode, oxidation reaction takes place. Here anode is lead plus electrolyte is sulfuric acid. Lead plus that sulfuric acid contains sulfate ions. Lead is a solid, sulfate. Electrolyte is 38% sulfuric acid, means which is in aqueous state. Gives rise to PbSO4, lead sulfate plus balance the electrons. 2 moles of electrons. Lead plus sulfate ions gives rise to lead sulfate plus electrons. Next, at cathodes. At cathodes, reduction reaction takes place. PbO2. Cathode is a grid of lead packed with lead dioxide. PbO2 plus sulfate ions, electrolyte is sulfuric acid plus H plus ions gives rise to PbO2 plus sulfate ions gives rise to PbSO4 plus 2 moles of water. Balance the charges. Here -2 plus 4, then add 2 moles of electrons gives rise to PbO2 plus sulfate plus H plus ions plus 2 moles of electrons gives rise to lead sulfate plus water. Lead dioxide, solid, which is in solid state, sulfate, which is in aqueous state, sulfate ions, aqueous, even H plus ions also aqueous state, gives rise to PbSO4 is solid, which is solid, H2O liquid. PbSO4 plus 2 moles of H2O. Lead sulfate is in solid state, lead sulfate is solid, H2O is liquid. This is solid. This is anodic reaction, this is cathodic reaction. Overall reaction, Pb plus PbO2 plus 2 moles of H2SO4. Electrons will get cancelled. 4 H plus ions plus 2 moles of sulfate ions. 2 moles of H2SO4 gives rise to 2 PbSO4 plus 2 H2O. Lead solid, lead dioxide solid, H2SO4 aqueous state, lead sulfate solid, H2O liquid. This is overall reaction. In that lead storage battery, anode is lead, cathode is grid of lead packed with lead dioxide, electrolyte is 38% sulfuric acid. During the usage of battery, these reactions take place at electrodes. During the usage of this lead storage battery, at anode this reaction takes place, at cathode this reaction takes place. This is overall reaction. During the charging of that lead storage battery, backward reaction takes place. During the usage of this lead storage battery, concentration of sulfuric acid decreases. Here electrolyte is sulfuric acid. Electrolyte is that H2SO4 is present reactant site. During the usage of this battery, these reactions take place. That means concentration of sulfuric acid decreases. During the charging process, H2SO4 concentration increases. Means backward reaction takes place. This is lead storage battery. Next, last one is nickel cadmium cell. Nickel cadmium cell. So it has a longer life than lead storage battery. This nickel cadmium cell has longer life than lead storage battery, but its manufacture is expensive. This nickel cadmium cell manufacture is expensive. It has longer life than lead storage battery, but its manufacture is expensive. A reaction takes place in this nickel cadmium cell is cadmium plus nickel hydroxide gives rise to cadmium oxide plus nickel hydroxide plus H2O. This cadmium is in solid state, nickel hydroxide also solid, cadmium oxide solid, nickel hydroxide solid, H2O liquid. This reaction takes place. Only this much is enough about this nickel cadmium cell. So everything is balanced. Cadmium. one nickel, one nickel, three oxygens, three oxygens. So here cadmium oxide plus 4 oxygens are there. Then balance like this, 2, 2. Now number of oxygens 6, 4, 5, 6. Everything is balanced. Only this much is enough about this nickel cadmium cell. This is about batteries.